December. All right, so before the break, we talked about Charles' law and Boyle's law. Let's review Charles' law real quick. We said that Charles figured out that if temperature goes up and you have a gas, you have an enclosed gas. You don't let any extra molecules of gas in or out, and you don't change the pressure. That if the temperature goes up, the volume will go down. That is to say, it has to be a container that can change the volume without allowing the pressure to change. Okay, and also, if the volume goes down, it'll force the temperature change. The temperature will also go down. And the result of that mathematically is that if we put volume and temperature in a fraction like this, you have a constant. So if you change the volume, the temperature is going to change, always keeping the overall value of that fraction the same. That's what a K means. It's a constant. That's what a constant means. Okay? Well, the practical use of that in terms of solving problems in high school chemistry is that the first volume and first temperature is always going to be the same ratio as the second volume and second temperature. Okay? And so if you know three of these unknowns, or these VT things here, these symbols, you can find the fourth one. Okay? And if you graph this, you always get a graph that has a straight line positive slope that intersects the origin at some point. Now, technically, you don't ever actually intersect the origin. But that's actually how they figured out what, theoretically speaking, what absolute zero would be. Okay? Because remember, when you get to really, really low temperatures, these kinetic molecular theory things, these laws based on the kinetic law, don't work anymore. Right? And so when we get to really, really low temperatures, we're near the origin, it doesn't really work anymore. So it's kind of an estimate, but it really helps us to figure out a lot of things that we wouldn't otherwise know. Now, this only works if we don't change the number of molecules of gas. Now remember, molecules and moles are not the same thing. Alright? But moles are a bunch of molecules. Alright? If you have 6.022 times 10 to the 23rd molecules of gas, you got a mole of gas. Okay? Like a dozen. Right? 12. But a mole is way more than that. So if it's not changing, then this means it's a constant. Alright? And in order for Charles' law to also work, the pressure doesn't change. You must keep the pressure from changing.
So if it's not changing, it's constant?
Yeah, if it's not changing, it's constant. Alright? So just to make sure we're kind of up to speed and everything, let's do a practice problem, okay? You can work with a partner, a learning partner. Let's get it done rather quickly. I've got a lot to do today. We have 15.0 milliliters of neon gas. Has a temperature of 200 K, 200.0 K, and the volume is increased to, let's say, 20 milliliters. what would the temperature be? Okay? So please solve this problem quickly, and we'll move on and review Charles' law, and then we'll go to some new stuff. Alright, so the first thing you're going to do is to make your list of knowns and unknowns, including the variables listed out here, because using that list of variables, you can choose the correct equation. Alright, now, on the test, and later in the next day or two, you'll be having to figure out which equation to use on your own. Right now, it's kind of like I'm setting it up for you, okay? But in the future, you're going to have to figure out, well, which one of these equations do I use? And you do that by looking at this list right here, okay? Because this is the list of knowns and unknowns. This is the equation that includes just that list of knowns and unknowns. That's the one I'm going to use. Then you plug in what you know. And when you come up to a situation like this, where temperature's on the bottom, you got to flip it because you can't solve for an unknown that's on the bottom, at least not directly. You've got to get it on the top. So we're going to flip both sides. Putting your best wrestling move on it. Yeah, you can go to the bathroom. Okay. And then you're going to isolate the unknown. The unknown is T2. Where we get T2 isolated on this side of the equation, the right side of the equation, is to multiply by 20 milliliters. Yep, there you go. Put it over 1. Once I find my red pen. All this cancels then. Milliliters cancel. You solve for this part of the problem, 20 times 200 divided by 15. Then you got to round off your answer to the correct number of significant digits. This is a multiplication division problem. The measurements with the least digits are these two. We have 3 digits each, so we want our final answer to have 3. I'm going to underline everything after the first 3 digits and round it off, and you get 267. K is T2. Hooray, hooray.
First problem I think I've ever seen and got right.
You know what? You would be getting a lot more right if you were focused. Maybe you're more focused today. That's great. Okay? If you stay focused in class, you can do this stuff. All right? Great. All right. So let's just review very quickly Boyle's law then. All right? We're probably not going to do a Boyle's law problem. It's actually even simpler to solve. I'm just going to review it for you. Just the equation itself. Remember Boyle's law. Boyle figured out that if you increase the pressure on an enclosed gas, for which the temperature doesn't change, and the number of moles of gas don't change, so that means temperature and moles have to be, I don't hear one person answer me. Come on guys, help me out here. If we're only changing pressure and volume, then number of moles and temperature have to be, I still only heard 2 people that time. Come on, help me out. If pressure changes volume, but we don't change anything else, temperature and number of moles have to be, that's a lot better, but I still see people back there who aren't even paying attention. Come on, guys. Come on, help me out. All right, if pressure goes up, volume has to go down, or in the alternate situation, if volume goes up, then the pressure has to go down. Okay? Well, what that means in practical terms is that pressure times volume equals a constant. Because when you multiply them together, you get a constant. And the practical use of that is an equation that looks like this. P1 times V1 equals P sub 2 times V sub 2. Okay? And that makes an inverse relationship where one variable goes up while the other goes down. And it looks something like this when you graph it. Okay? That's kind of sloppy looking, but that's kind of what happens.